Welcome to my CompTIA Security Plus lecture review. Here we're looking at Chapter 9, Wireless Network Security. This is out of the book CompTIA Security Plus Guide to Network Security Fundamentals, 5th edition. Alright, so Chapter 9 is all about wireless. We're going to describe the different types of wireless networks, the types of attacks, vulnerabilities, and explain some possible solutions for some of them. Alright, so wireless attacks come in three major areas. Bluetooth attacks, NFC attacks, that's near field communication, very similar to Bluetooth but not quite, and wireless LAN or wireless local area network attacks. So Bluetooth is a wireless technology that's used for short-range radio waves, or it uses short-range radio waves. It is more of an ad hoc, meaning on-the-fly topology, meaning no centralization. Good example is like Bluetooth from your phone to your headset, your phone to your car, wireless keyboard and mouse to your laptop, things like that. Things that are going to be more of a personal area network or PAN, small area. Two types of Bluetooth topologies, PicoNet and ScatterNet. ScatterNet is a type of ad hoc network, basically where the network consists of two or more PicoNets, and the term ScatterNet and PicoNet are typically applied to Bluetooth. So again, a ScatterNet is multiple PicoNets. A PicoNet is an ad hoc network that links a wireless user group of devices using Bluetooth technology. A PicoNet specifically consists itself of two or more devices occupying the same physical channel in a small or localized area. Bluetooth attacks, we have some, I don't know why these are classified as attacks, because they're really not. Categories like automobile, basically you compare your phone to your car. That's not an attack. Photographers, gamers, sport and fitness, if you have like an iWatch, it will connect to your iPhone via Bluetooth, and so forth. Again, those are not attacks. Those are just examples of where Bluetooth could be used. PicoNet is established when two or more Bluetooth devices come within range of one another. Typically, this is a master-slave relationship. Active slaves are sending transmissions. Parked slaves are connected but not actively participating. That's important for a later slide. So here we have an actual master, and then we have a few active or parked slaves and how they communicate with the master, because the master is going to be the one that controls the communication flow. ScatterNet, again, is a group of PicoNets, and here we have a active slave connecting to multiple masters and sending information through them. We have Bluejacking. Bluejacking is a type of an attack. The nice thing with Bluejacking is it's an attempt to send unsolicited messages to a Bluetooth-enabled device. Basically, you try sending messages or images. It's actually really funny but really sad. But New York, New Jersey area, you actually have people in the subway sending adult photos to all mobile phones that they're around. And so as you're riding the subway, you're actually just getting bombarded with images that you probably don't want to see. Bluejacking is more of an annoyance than harmful, because the goal for bluejacking is not data theft. Blue snarfing is an attack that accesses unauthorized information from a wireless device through Bluetooth. This is more often done through mobile phones and laptops or other mobile devices. The attacker basically tries to copy off emails, contacts, and any other type of data via Bluetooth without the owner's knowledge. Alright, so that was Bluetooth. Moving on, we have our near field communication, NFC. And this is a set of standards primarily for smartphones and smart cards that can be used to establish communication between devices in close proximity. So this is not quite wireless like Wi-Fi as we would expect. Think more like RFID. It's just one example. NFC devices use connectionless payment systems. Can't think of the name of the system, but like you can use Apple Pay, get close to a wireless sensor from your Apple phone, and then it can actually transmit payment information. Common types of attacks: eavesdropping. You can always do data manipulation, man in the middle, and then device theft. Which really, device theft is not an attack per se, but it is a security concern. Moving on, we have a wireless LAN, or WLAN. And basically this is, when we think wireless, this is what most people think. This is traditional 802.11x, either 2.4 gigahertz or 5 gigahertz. Apparently my pop-ups today just don't want to stop. 802.11x has different types of transmission speeds and frequency manipulation or modulation, and different types of security measures, and that's what we're going to be getting into. So again, it's 802.11. Normally there will be an X at the end, X being not X as the letter X, but X is a variable, because we have different standards: A, B, G, N, AC, AI, AD, and so forth. 802.11a, 54 megabits per second, but it uses 5 gigahertz only. B is apparently being skipped. That was 11 megabits per second, but it used the more common 2.4 gigahertz spectrum. After that, we got 802.11g, which was faster speeds, but using 2.4 gigahertz. Then after that, 802.11n. And then we have now 802.11ac. Nice thing with AC is AC uses both 2.4 and 5 gigahertz, regardless of what this diagram says. Maximum data is a lot faster, has a little bit shorter of a range, but that's to be expected. We also have newer standards like ACI, ACE, AD. AD, though, is not really ratified just yet. Alright, so moving past this, we have common types of devices used on our wireless networks. So when I say wireless, I'm thinking Wi-Fi as in 802.11x. WLAN has things like an access point. An access point is what connects wireless devices to a wired network. It will act as a bridge between wireless and wired networks. They act as a base station. We can also have a combination device where it will be a wireless broadband router, a wireless broadband router / switch, and like a home user. That's going to be a router, a switch, and an access point all put into one. And sometimes I wonder if authors just make up things. Sometimes these wireless broadband routers are called WLAN gateways. In reality, it's a SOHO, small office, home office appliance. And here we have our access point. So I don't really agree with this diagram. Here we're showcasing the Linksys type device as a access point only, not as a SOHO router / access point, because you'll notice there is nothing going to the internet. It's just a wired network to the internet. So we have a few things lacking on this diagram. In network, a well-defined boundary protects data and resources. This is typically called the edge, the perimeter, sometimes called the hard edge, really just depending on who you're talking with. Wireless attacks have a few common types. A rogue access point, that's an access point that is not authorized, yet it's still broadcasting. An evil twin, that's when you can go to Starbucks and you connect to Starbucks' network, but you don't realize it's Starbucks. Or or you don't realize it's not really Starbucks, it's really a man in the middle. Intercepting wireless data, that's when you actually have a wireless sniffer going on, and it actually is now recording or capturing wireless packets. Wireless replay attacks or denial of service, that's where you can capture wireless signals and you replay them later. Rogue access points we've already talked about, an unauthorized access point that allows an attacker to bypass network security. More often you see this with a office worker that wants his own personal Wi-Fi, so he unplugs his data jack at his cubicle, he plugs in his own access point, and then voila, that gives a wireless access to that wired network, bypassing completely the company's or organization's network security. Evil Twin we already talked about, an AP set up by an attacker, made to mimic an authorized access point. Here is an example of a rogue access point. Intercepting wireless data. Basically, if you can put your wireless card into monitoring mode, you can use a protocol analyzer to capture wireless traffic. Monitor mode is also called RF monitoring or RFMon. Basically, it allows it to just monitor and grab all wireless traffic. A replay attack is also known as hijacking. It's a passive attack in which the attacker captures transmitted wireless data, records it, and then sends it to the original recipient without an attacker's presence being detected. Normally done through an Evil Twin or like a Hack 5's Pineapple, which can act as an Evil Twin, though the Hack 5 Pineapple can do so much more than just that. Wireless denial of service. We could have things like an RF jamming signal. We could have spoofing or manipulating of the wireless data frames. RF jamming, basically you prevent the RF signals from being able to be transmitted or received. Wireless home attacks. Most home users fail to configure any type of security, so you can actually typically connect to like a neighbor's Wi-Fi, steal their data, read their transmission, inject malware if you want, or download harmful content. Basically pirate using their internet. A lot of this is done through war driving. Basically, you're driving around your neighborhood trying to connect to open Wi-Fi. That's war driving. Things that we have to understand are wireless NICs, how they work, the antennas and the different types of antennas, because not all antennas are created equal. War chalking. Basically, if you've ever been to an organization and have open Wi-Fi, outside you may have an interested third party might draw a symbol like on the sidewalk or on the wall, letting others know that you can attack that network. That's called war chalking. And here are some common symbols for war chalking. So let's move on to the vulnerabilities of wireless security. Implementing several types of wireless security protection in the standard design is important, though not all form of security is created equal. One of the first types of encryption was called Wired Equivalent Protection, or WEP, WEP. WEP's vulnerable as it only uses a 64-bit or 128-bit number of encryption. And the sad part here is it's really easy to break into. The shorter length makes it way easy to break, and there are other vulnerabilities that basically allows an attacker to capture a few packets and quickly decipher the key. In all honesty, you should take about 5 to 10 minutes after capturing a significant amount of wireless traffic to break in or to steal the WEP key. One of the nice things is this is all well documented for their how to break. It violates cardinal rules of cryptography, avoid a detectable pattern, So the attacker can see duplications when the IVs start repeating, and then from there reverse it. WPS is another type of configured security. There are two types of WPS methods, a pin or a push button. Basically, you'll have a wireless device. If it's a push button, you can push the button and you have X amount of seconds to connect to it so that the security configuration can take place. You can do a pin method, which is very similar as well. Design and implementation flaws. There is no lockout limit or timer for the pins. The last pin character is only a checksum, so that's an issue. The wireless router reports the validity of the first and second half of the pin separately, so there are some issues there. You can do the invalid pin but have the first section correct, not the second section, and all that fun stuff. So there are issues with WPS. Apparently we're not going to talk about the other two just yet. We can talk about methods of controlling access to the access point in the form of a MAC address filter. MAC addresses are a layer 2 address, and you can limit device connections to an access point via a MAC address. The vulnerability of MAC address filtering is addresses exchange in unencrypted formats, so you can always spoof a MAC address that is allowed to be on the network. Also, as you grow, managing larger numbers of addresses become more and more challenging. Think about a basic home user that may have 20 devices on their home network. When their friends come over to connect to their wireless network, you have to add in those MAC addresses. When they leave, you have to remember to turn them off, and that just becomes more and more tiresome. You can have different forms of MAC address filtering. Basically, you can say prevent or allow. Another common technique is you can disable SSIDs, or the service set identifier, the name of the wireless network. This is really funny because they tell you can disable the SSID, but this is a common feature that most people don't do, and if you have any skills, you can always pick up the SSIDs regardless if they're being broadcast or not. So, is this really secure? In all honesty, it adds a layer of protection, but is it sufficient? I don't agree. Not advertising the SSID only provides a weak degree of security, and it has a lot of limitations, meaning you have to hard program the SSIDs in the devices that are connecting, which for most users it's not going to be feasible. A unified approach to wireless security was needed, so IEEE and the Wi-Fi Alliance got together and they created WPA and WPA2, though both of these have their forms of vulnerabilities as well. Introduced in 2003 by the Wi-Fi Alliance, a subset of IEEE 802.11i was implemented, and the design goal here was protecting both current and future wireless devices, and so they implemented a temporary key integrate protocol, or TKIP, encryption, which this is what is used in WPA. It uses a much longer key than WEP, and it dynamically generates for each new packet. And there is also a message integrity check built into it. Basically, that helps prevent man-in-the-middle attacks, though WPA has its own vulnerabilities. WPA does also use a pre-shared key authentication, and it will use a passphrase to generate encryption keys. This must be entered onto the access point and the wireless device in advance, and this is not used for encryption. Serves as a starting point for mathematically generating an encryption key. Vulnerabilities is key management and the passphrases. The passphrases are fewer than 20 characters, and they're really easy to crack. Realistically, 20 to 30 minutes for more of like a beginner to break WPA. WPA2 came out a little bit later, and it does allow wireless clients using TCP to operate in the same wireless LAN, but it replaces it with AES CCMP. In all honesty, AES is a block cipher. AES performs 3 steps on every block, so it makes it a little bit more complex, but it makes it a lot harder to break. It does allow for encryption. The counter mode with cipher block chaining message authentication code, CCMP, is the encryption protocol used for WPA2. Specify the use of CCM. They will also have a cipher block chaining message authentication code, CBCMAC component of CCMP provides the data integrity and authentication portion. Both CCMP and TKIP uses 120-bit key for encryption. And in all honesty, I've never been asked detailed questions about this. I don't think that we have to go quite this in depth when you're studying for your Security Plus. Though in a previous lecture we talked about 802.1x. The nice thing is 802.1x authentication, which was developed for a wired network, can also be used with WPA2. WPA2 also uses the Extensive Authentication Protocol, or EAP, created as a more secure alternative than CHAP and PAP. Basically, this is the framework for authentication protocols. It will define the message format, and it uses 4 types of packets: a request, response, success, and failure. There are 2 common types of EAP, which are a lightweight EAP and a protected EAP, LEAP and PEEP. LEAP is proprietary to Cisco. PEEP is a simplified deployment of 802.1x by using the Microsoft login and password without the need for additional services. It does create an encrypted channel between the client and authentication server to share. And here are the different types of EAPs. We have a captive portal for APs, which uses a standard web browser to provide information, giving the wireless user the opportunity to agree or to disagree, or to even provide login credentials. Basically, when you go to Starbucks or McDonald's and you have that splash page, do you agree to the terms and services? Click here to proceed. That's that captive portal. Rogue access point discovery tools. There are 4 types of wireless probes: wireless device probes, desktop probes, access point probes, dedicated probes, and there are more than that. That's just what our author wants you to know. When we're talking security, we also have to talk at power level controls, because you can control the power level of certain antennas on certain access points. Also understand that antennas come in multiple flavors. You have directional, and you have omnidirectional, and you have bidirectional. So you can manipulate the power of the access point. You can manipulate the power on each antenna, and then you can also change out antennas so that the signal goes whichever way that you want. How do you know how to do it? How do you know if you have the appropriate wireless coverage? You can perform what's called a wireless site survey, and basically you walk around with a site survey piece of equipment, and it will determine the wireless coverage in a given area. Don't just use a free app on your phone, actually get a wireless site survey tool. And that is the end of this chapter. Again, this is just more of an intro to basic wireless and wireless security. If you have any questions, please leave a comment below. I'll try to get those answered as quickly as I can. Thank you.